All right, it's Thursday, so we'll try to continue the same process as last week for Thursday. So we'll spend the first like half an hour of the class doing a discussion of uh, the top or this from the QQTP, what questions and talking points, that sort of stuff. I'm going to try to do that a little differently today. And have it more of a discussion. I don't want to be last week it seemed like I talked too much during that section. I don't want to talk as much. I like to hear more from you during that. So I'm going to try to turn the camera around and we're going to try to sit in the middle of the room and have this discussion there. And I want to hear from the online students if you can hear and participate with us in that. I'll make sure, how's my volume doing here? Yeah, so we'll see how that goes. And we'll see if we need to bring in an external mic or something like that in the future for this. So we'll do that. We'll do this discussion for the first half hour, and then we'll break into pairs and work on the learning activity worksheet today. And again, we'll try to, if you're in class here, we'll try to assign you with a pair in class. It looks like we have an even number in class right now, so that'll be good. And then Zoom people will assign you to partners, 2 or 3 there. And then we'll, anyone who's asynchronous, we'll assign them to teams also. So we'll do that during the second part of the class. So and I just want to note, so this is a new class, some new methods we're doing. So next week, I'll be asking you for some feedback after we've done kind of, 2.5 units of this. How do you think it's going? What can we improve? I'll just tell you, a lot of courses I've taught, 10 times, and I've found a pretty good rhythm that I kind of like in the course, but like this is a brand new course and I really need your input on how to improve it and set it up. I don't have a great feel for, what this course should be. We're using some, AI differently in this course. We're doing some other things differently in this course. So I'd like to hear from you. So next week, watch for a quick survey in Brightspace on how we can improve this course there. So, okay, so let's get into the QQTP here. So hopefully you went through the prompts from this week. So a couple ways you have to do this discussion or this interaction is you can use the Brightspace discussion forum to post, I've seen, I already saw quite a few people posted things there and replies and some nice detailed replies there and stuff like that. So that's good. I'm going to be bringing up this discussion document here. It just this morning, I just copied over a bunch of the topics or questions here just to kind of have that in front of us. And again, you can, if you want, just go through here and you can add comments in class today talking about this sort of stuff for this. We'll have that up. And then we'll actually have this discussion. We'll try to have this live discussion. And if you participate in the discussion, I'll just put a little check by your name and that'll count as part of your participation. You have to have at least 2 discussion interactions every week. So besides your original post, 2 replies or interactions after that. So, all right, questions on that? Okay, I'm going to try to turn this around. Then I'm going to switch. Oh, yeah, I think we're going to switch this so that it's just, I'm not sharing here. And then we'll try. All right. And I'm going to bring up this discussion topic here so we can have that up on the screen also. All right. And I'm going to go over here. By my favorite student for the day, right? Yes. And so, okay. So let's try to talk about some of this stuff. So I guess I invite you, did you have a question or a talking point that you posted that you would like to put out there? Well, first, online students, can you hear me? Can you hear us? Johnny? We can't hear you. There's something in chat. Yes, I can. Okay, good. Apparently they can hear us. All right. Okay. Yeah, I don't know if we can hear you, but we have the chat open, Johnny, so you can post discussion there too. We'd like to hear you for just a second. Okay, so someone want to chime in on a question they had or a talking point? Please.
Yeah, that first talking point, since BNF is a standardized way of syntax.
Yeah.
That's the question I had. And what other like background processes like happen, like whether they're like forms of syntax or whatever happens in coding languages.
Right. And I think we saw someone posting some ideas from that in the discussion area. So yeah, so BNF is really just a way of specifying the syntax of a thing, but there are other ways of specifying some syntax here. But or at least breaking down a syntax in different ways. One thing we'll look at is parse trees or syntax. Well, I guess I mentioned, I think, syntax diagrams last week as more of a graphical way of specifying that. So often languages will do that stuff. Like if you've seen, what kind of documentation have you seen for programming language and how have they specified the syntax of a language? So if you go, if you look at a Java manual or a Python book, they don't, a lot of them nowadays don't specify that. How would you see them specify like an if statement? And what are the options for if statement in documentation or something like that? Have you seen, I often use it, see them more like written down, like here are the possible statements, and you say like if, and then maybe a parenthesis, and then they'll just write in like Boolean expression, or they'll put Boolean expression as some marker there, like maybe in italics or with brackets around it to say that's not the word, but that's something you put in there. And then they'll, so they'll just list out the sample sentences. Yeah. So, and again, that's kind of maybe a more human-friendly version of BNF kind of sort of idea is that, you have these, and then you could look up Boolean expression in the manual and would maybe tell you, but although sometimes they don't actually define what a Boolean expression is, they just assume you know what that is. Do you see ones like that?
I'm just looking at the Java documentation. It says like they'll use like whatever class or syntax is, so it's like a date or a boolean or whatever.
So they just kind of list it?
Yeah, it's kind of listed.
And again, another thing I think we'll see is these parse trees. Once we get into parsing, and this is a little different, but what we'll do is we'll take a sentence like this and we'll create a parse tree showing how it's broken down into these tokens and what it is, and we'll look at, you know, how you go through it. If you're just reading character by character through a command, how do you then parse it and generate a parse tree for that? And now I'll get into some of this stuff like why can't, you know, it's a really weird word. Why can't identifiers start with a number? Why can't you have a variable start with a number? Why does it have to start with a letter? One of the reasons that when you're parsing it, you come to a number, you want to know that that's a number and not a variable there. So you have rules like that. We'll look at those parse trees next week. We start getting into that, or the week after. Oh, another topic. Another question. What was your talking point? One of the ideas of talking points, then you don't have to like think of one. You have one ready to go. You can just state it. It makes this a lot easier to do. So it also makes it so I can call on you directly and ask you what to talk about. But I'm trying to avoid that at present. Oh.
For my talking point, I like mentioned AI, how it's rising a lot more now. So
Right.
I was wondering, I guess, like how DNS and DNS, if they're gonna need to accommodate to like more flexible, like human readable, this or like paradigms with AI.
Yeah.
So,
Do you think? So AI is being used to generate blank or, you know, to write code a lot.
Yeah.
Do you think code, you know, then we're gonna change the code to in some, you know, way? Yeah, well, that because to accommodate AI a little more or not? And how would, yeah, what do you think of that? How would it change? I do see, you know, over time, and someone else asked this a little bit, you know, how programming language, like how Java has changed and stuff like that. And so, or like what happens if a language changes? So, like, so Python now, I think you have only, when you know Python, you only know what we call Python 3. I don't even know if you know it was called Python 3, but we used to teach Python 2. And Python 2 was actually quite a bit different than Python 3 as far as the syntax goes and what you could do. Like in Python 2, you would say like print space in a variable. And in Python 3, you have to say it's like a function called print parenthesis what you want to print parentheses. So you have to put everything in parentheses, where in old Python, you just say print space and then what you wanted to print. You didn't do it like a function call there. And like in Java, we're going to get into lambda expressions and lambda functions, which are relatively new and come from functional stuff. So I mean, certainly these languages, you know, so we're on what, Java 8 now? I don't remember when lambdas were added, like Java 7 to this stuff. And so certainly languages change. I mean, like for a long time, when we had both Python 2 and Python 3 around, Python 3 was new, but most of the code was still written in Python 2. It was just a pain because you go online and look for any sort of help, you know, thing, and half of them were in Python 2 and half of them were in Python 3, and it was you know, really hard to figure out when, you know, when it applied, because all of the people who wrote all the postings when Python 2 was out, I think, never said, oh, this is Python 2, because we didn't have Python 3. You would never say, you know, this is the old way of doing it, because it wasn't. It was the new way of doing it there. So, yeah. What do you think would be a change that might happen to allow AI to help write code more with us?
like more updated, sources, documentation, because if it's still taking something like past Java versions, like maybe it's, struggling to write correct code.
Right.
Also, it can't write its own code, or it's like it can't run its own code, so you can't really test that.
Yeah, so far right now, it's not able to run its own code, so maybe something that would allow it, maybe even to run its own code a little better, or something like that might be useful. I wonder if some of the flexibility, like, there's now multiple ways of doing something in Java, and maybe it would, I wonder if, it would be more likely to get rid of some of that flexibility, and so that you always, there's only one way to do this, so that AI wouldn't have to figure out which way to do it, just say, this is the way we do it, even though not everyone likes it that way. You're just gonna have AI write it, so AI would just always do it this way. I do notice, and one of the reasons I say that is that students now tend to learn the way that AI does things a lot. So I notice, like, if there's a structure for doing something, because students are often using AI to generate code, so they will do it that way. And even when they're not using AI, that's the way they've seen it, so they do it that way there. So part of it might just be almost AI is going to replace or kind of help have everyone write it a standard way, because the AIs are going to just write it the standard way for that. I don't know. All right, another topic. Oh, for my favorite student. Favorite student status. You get a fair amount of responsibility for being the favorite student of the day. So Grace is just over there going, oh, I'm glad I'm not his favorite student.
So that's the honor, John.
What?
That's the honor, John.
Uh-huh. Yes, it is. Right.
My question is like, how DNF kind of determine if we make a mistake in our statements or syntax, because it's very robust, and it's kind of hard to determine for a robot if we made a mistake or not. So that was my question.
Yeah. So how can BNF determine a mistake? So yeah, and that's what from BNF, we'll get to what are called context-free grammars, which will be the languages, and then we'll use those to parse these languages. So parsing means, if you have a string of characters, basically we'll take a string of characters and we'll then create what is called a parse tree, where we'll take tokens like the word if, and this, and this is an identifier, and this is a number, and we'll parse it all, and we'll break every statement down into a tree of basically how we apply the BNF rules to it, what order we apply the BNF rules, and every rule will then break down into part of this tree, and then if you're doing that tree and you can't get to like what we call n tokens, for every branch of the tree, then it means you can't parse it, and then you have a syntax error. So again, if you can't figure out how to apply these rules to break down this sentence into the final thing, final reserved words and stuff like that, then there's a syntax error. And that's by definition what a syntax error is that if we can't parse it, if we can't figure out how to use the BNF to convert, to understand it, break it into tokens, by objects. And then again, and you'll get, that's why you get syntax errors when you are just compiling it, not when you're running it, because the compiling is just the parsing it, and then it is the first part of compiling, and then the rest of it is optimizing it and generating machine language and stuff like that. But first thing, you have to parse it. Yeah. I mean, one of the things people will see, ask, I think, are the type of error messages that you get with syntax errors and why. And you'll begin to understand a little bit, some of that is just so cryptic. I still, why you get certain error messages and why you can't figure out where the error is very well. And so we begin to see that when we start looking at parsers. And we won't look as deep as I mean, there's a lot of stuff on parsing, so we'll just see. But you'll begin to understand why it's sometimes hard for the computer. Why, like, if you're missing something in one sentence, one statement, the computer often gives you a error in the statement below it or something like that, saying, things like that. Your semicolon is missing, but it won't notice that until it gets to the statement. That. Okay. So Grace, I warned you. I told you. I did, didn't I? Did I warn you? I gave you a heads up there. So give me something, Grace. Yeah. And now some people are asking about the different, like, the 4 types of grammars and stuff like that too. Here, and are there languages that I think you were asking, like, are there languages that we would want to define that are beyond what we can do in context-free grammars? Is that kind of... Yeah, those are good questions. So maybe they are, but one of the problems we have is that all our tools for parsing computer language and stuff are basically based on context-free grammars and understanding the rules and all that stuff. So we don't have and again, I don't do research into programming language. I mean, there are people who just, their PhD is on creating a new programming language and a new way of parsing programming languages and stuff like that. And that is certainly not me. So that would be at the end when we will do some, you'll get last 2 weeks a chance to dive into some deep topic, and that might be a good topic, because right now all of our tools out there for like, if you wanted to just, I mean, you could spend a weekend and define a new programming language and build a parser for it. There are tools out there, but again, it would have to be, you have to create a context-free grammar for that language, and the tools will work with any language that is that way. So that's why I think I don't know of any languages out there right now that aren't covered by context-free grammar, or at least I should say any computer languages out there. You can certainly. Yeah, non-computer languages are much more complicated. And there are certainly ways of defining, like we talked about those 4 types of grammar or languages. We bring it down into this 4th type, which are, you can make very complicated languages that you can generate really weird statements for. But we have trouble then creating a parser for that, and trying to, in a programming environment, writing a program that would, again, be able to convert a series of symbols into that language there. And so that's why everything is basically at that level. We know, we've proven how to parse and manage those context-free grammars. With, again, and even we're looking at the BNF rules, always will have a single symbol on the left side of a BNF statement, and then options on the right side, because that's what our parsing stuff is. All right. Okay. Johnny has a talking point. Here's my talking point. I'd like to talk more about the difference between semantics and pragmatics there. So what do you understand of, so we talked about syntax being the parsing, there. What is semantics and so what is the difference between syntax, a syntax error and a semantic error?
Programming. Another one is,
Semantics, yes.
semantics is, after it's compiled.
After it compiles, yeah, it compiles and then does it run okay, like,
Yeah, like crashes software.
yeah, right, or maybe it does something wrong after it works, there, so I often think like, often beginning programmers, like, they'll start in CS0 where all their lists are indexed starting at 1, and then they get to Java. And so they write their first for loop to like add up all the numbers in the array, and they so for, for I equals 1 to the size of the array, not for I equals 0 to the size of the array. And so they'll add up items in the array, but they'll always miss that the first element, the 0th element, because they're used to counting at 1. Again, the compiler won't catch, I mean, yeah, it's a legal way of doing it, but it still won't get the right answer, right? So that's semantic error. And again, it'll run fine, actually. So what are pragmatics? Have you heard that term outside of computers? Are you a pragmatist? What is a pragmatist? Johnny, what's a pragmatist? He's looking it up. Oh. Okay. Someone who's pretty utilitarian, there, does the minimum or follows the rules exactly, doesn't read anything into them or apply maybe ethics to, or there, that sort of stuff. Okay. This does the job. So again, in computer stuff, I guess the question is, why, kind of at the next level, what is it? Is this program doing something good or bad, or what, what can we apply our ethics or our, values or something besides just functionality to this? So again, to me, semantics is about functionality. Does it function? Does it do what it is? And again, you talk to someone who does project management or something like that, they'll say, well, you just define the design, does it meet all the specifications? Semantic might mean, does it mean all the specifications? And then I think pragmatics are the specifications right? Is this doing, and are we doing, is this something we want to do for this? So are we missing some stuff in how we're specifying this stuff?
So pragmatic, is that like technical?
I guess a little bit, but also like, yeah. How would you define pragmatics?
I don't know, like someone who's pragmatic, someone who's concerned about the
Practical part of it, yeah, right. So, well, what's the textbook define pragmatism, or what's AI say pragmatism?
I was gonna say, like, also from the ChatGPT, it's like saying how, like, even the way that the style of coding is or the usage of it, like,
Right.
if you use like enhanced coding versus a regular coding routine, like, what's like the most practical way to go about it, I
Right.
guess, like, that's also
Okay, yeah.
my ChatGPT.
Yeah. So, because there's lots of ways you could do this, maybe syntactically or semantically and syntactically, right? But you have some preference for a better way of doing it. But, I always think even this, like, what do you choose for variable names and how you set that up might be part of that. why don't we start breaking ourselves into groups, here. All right. I'm going to. Make this now. Okay, let's see, who do we have here? Okay. Two. Got an odd number here. Okay, so we'll see how that goes. Okay, we're gonna let random colors determine your group. Here, so. Okay. So we'll get you together in pairs there. And we'll, how many people we have online? We have 3 people online. Who in person got the color? Okay, so you're going to be assigned with someone online. So if you can get on Zoom also, there. The rest of you find your match. So we've got Addison, Johnny, oops. Is it? Jeffries. And Simba. Allie, are you with Grace? Is that what I'm seeing? And Kita is with Eva. Okay. Okay, I'm going to set for online people, I'm going to set up 2 breakout rooms here and let you go into the breakout rooms here. Whoops, what's this right? I think you can decide what breakout rooms you can go into. So Johnny and Addison, why don't you go into room 1 and Taku and Simba go into room 2, how about? I guess I could have just done that to you. I think I can do it actually. Okay, there. Okay, then you should go to the worksheet here, make a copy of it and start working on that. Sound good? Okay, I'm just gonna break in for just a sec. Let me put this up on the main screen, I guess. Um, if you're into part two, you go look at this grammar where you have pluses and multiplication stuff, and it talks about precedence. And I just want to explain one thing about that that we'll actually get to a little later next week, but it doesn't seem to make sense to me right away. We want to do multiplication before we do plus here. But the first expression has a plus in it, and the second one has a multiplication in it there. And why would that be? That seems wrong to me. So I'm just going to bring up this example. This is from another textbook by Scott that I use some. This is two ways of parsing an expression. The slope times x plus the intercept is their example here. And notice like this is the preferred way where we have, in this part, we have the slope times the x down here lower in the tree because this will be done first. And then once we figure that out, that will be added to the intercept. So it's lower down in the tree, even though it's higher precedence here. That means it'll be done first here. Where this one, the x plus the intercept is down, those ID, that's down here. And that'll actually be done first. And then the slope times that will be, whatever that expression is, will be done after. So this does the plus before the multiplication here. So just so you know that, and we'll get to this more next week, but I just want to do, this question just gets you kind of thinking about why you might want to separate multiplication from plus if they have different precedents. And so you can kind of maybe visualize these trees and how you'll want to have in your tree parts, places where you do like a multiplication, and then you take that result and do that with an addition rather than the other way around. So just think about that. I think that might help you understand this part two a little better. Okay, I'll let you go back. I'll send you back in the break rooms too. One final note, so it looks like a number of people were able to get done with this learn activity, was good. Remember, then you have the assignment to do by Sunday night there. And the assignment uses a longer grammar that's in this textbook here, a bigger, more complete grammar for a made-up language, simplified language called Ren there. So you can work on that now or over the weekend. So I'm going to stop this recording here.